Good morning and thank you for the welcome. My name is Dr. Joseph Foley and I'm from the National Centre for Engineering and Agriculture at the University of Southern Queensland in Toowoomba. And you might ask, what am I doing in Tasmania? Well, one of the things that we've been very fortunate to do is work with Sue Hinton and the team, James Hill and Dave McLaren from TIA, and we've had a great time operating across multiple projects here in Tasmania, working on the big problem that most of the gents this morning have been talking about with variable rate issues and variable rate application is water. And my focus throughout the work that I've been doing with the University of Southern Queensland has been to focus on irrigation. And as the Irrigation and Water Management Program Leader, we've had a lot of activity over many years, and I'll just give you a little bit of a brief introduction to some of it, just to indicate to you some of the capabilities that exist, freely available, to help you with irrigation system improvement. So at the NCEA we've had a long history of developing visualisation tools and optimisation tools that also assist with the design of sprinkler irrigation systems, and we've got everything there from centre pivot activity through to travelling gun machines, with recent PhD activity around end gun performance, and also right through from the sprinkler performance in wind through to the hydraulic performance of some of these larger systems and machines. There's three really important measures whenever you start to talk about sprinkler irrigation system performance, and I'm going to briefly touch on those, including those around system capacity, uniformity, and then application efficiency. And the reason that over the years that we've taken a focus onto these three aspects is because unless you get these things right with your centre pivots irrigation systems or any other sprinkler irrigation systems, these simple things, everything else is a waste of time. You've heard on a couple of occasions this morning the massive impact that irrigation water does have on the variability across fields, and our focus continually for the last 20 years has been to assist people to understand and iron out some of that non-uniformity. Let me just start with a little chat around system capacity, and I thank Will for reminding me about the presentation I gave on system capacity here 2 years ago at a presentation for State Water for Profit. System capacity, what is it? Why is it so important for centre pivots and lateral moves? Well, one of the things that's historically occurred with centre pivot systems in Australia has been the system capacity has been woefully designed. And what we've tended to have happen over the decades has been a very strong impact of poor performance of things like centre pivots because the system capacity was not good enough. Particularly a case where people are focused around full irrigation capability. When we're in a supplementary situation, as we have done on some of our properties and as Will is doing here, it's a different story. When you're actually trying to grow horticultural products and you need to be able to apply the water that's necessary to grow the crop, you've got to have that system capacity. So the system capacity is just simply the flow rate over the area, and you can translate that into millimetres per day. And it's essentially a number that you use to compare against your peak crop evapotranspiration, or the water use and the evaporation from the soil and the crop. And we have for many years talked about utilising some great work out of the CRC for catchment hydrology. Well, actually generated maps of the point potential across Australia, and you can start to then focus in on those areas and translate that average point potential for particular hot months and translate that directly into system capacity, which is one of the things that I've typically done when I've come down to this part of the world, mostly to actually pick a few blues with people around the system capacity that's necessary. So in this part of the world, during that peak irrigation month of January, the sorts of systems that you need to continuously apply good water to fully irrigate crop, and where the crop is of high value, obviously then there's a necessity to have these sorts of system capacities. This is not a supplementary situation but a full irrigation scenario. We're going to have this situation where you're looking at system capacities at a minimum in that 6.5 to 7 as you go towards the northwest, and towards to the northeast there in the 7.5 to 8 millimetre a day system capacity. Remember, that's not the amount that you apply each day. That's actually the flow rate that the machine has over the irrigated area. And there's many people here in the front row that can actually help you to calculate those if you're having trouble with it. Why do we even bother when we actually end up in a situation as James Hills and I focused on as a case study with some of the larger dairy pasture growers in this part of the world? We really trying to focus on that precision broadacre irrigation on these centre pivot systems, but some of the simple things are actually really important and sometimes missing. And so here's a case that James has talked about a number of occasions. We developed for a South Australian field day a few years ago, where we've actually got a scenario with the water balance on a field. We've actually got the irrigation events occurring on those little red bars. And the soil water balance in the profile, we're trying to keep in the green zone, which is about a 0 to 30 millimetre deficit. But what's occurred over time is that the irrigation system hasn't been turned on, and when there's been irrigation events, there hasn't been that water content in the soil hasn't been maintained in the optimum region, and we've actually ended up with a deficit beyond what good growth for pasture has actually resulted from. So there's a significant loss in dairy pasture production under scenarios where simple things like a soil water balance isn't being accounted for. There's simple tools to help you to understand how to manage irrigation systems like centre pivots, and many years ago we put this one together, and it's still freely available at that website. Operates on your computer or iPhone, iPad, and will allow you to come to grips with managing a moving irrigation machine around different parts of a field where you've actually got a particular system capacity that you can set. So you can actually start to play with low system capacity or higher system capacity machines, irrigation times on and off, and actually understand what the probes would actually run like. And though in that instance here, they're provided on the right hand side here, where each of these probe levels actually relates to a probe position put around the field. And those things just help, we found, with growers to actually understand how to manage some of these systems and get the maximum performance from them. So improving irrigation performance is really about managing some of these things, and these two key focus areas are typically around the uniformity and the application efficiency. The uniformity is about getting the water that you apply as even as possible right across the whole field, whereas the application efficiency is all about trying to lose as little as possible from the water source into your crop root zone. So there's no point running water off a field when you're irrigating. There's no point putting water beyond the soil moisture deficit and deeper into the root zone and past the root zone at the base. You're actually trying to get every quantity of water, piece of water that you pump into the actual root zone itself. So one of the ways that we typically try and introduce growers into getting to do something about these facts is to just have a go. Measure something yourself. We can typically come in and measure these things, and we have done on many occasions, but one of the things that's really important is to have a go. Measure something. Start simple and actually begin the process of learning about how your irrigation system operates. Automated systems or remote control systems actually give the capability to monitor some of this more easily on your smartphone, but any of these things is actually useful. It's often these simple things that can deliver pretty large improvements in your irrigation performance and your profitability. So we don't necessarily have to go to the very high-tech level to get good performance. When we look at the uniformity, one of the key factors that really drives these things is we can always see a yield variation related to the uniformity of the water application. In some instances we've got excess water, in some instances we've actually got under irrigation. The relationships are very, very good no matter where you go. And here's an example in horticulture where we've got 2 sprinkler irrigation lines and a significant variation across that 8 to 10 metres of sprinkler spacing in both the applied depth and the yield. And you can see them matching very, very well. It's always the case that water drowns out a lot of other variability. So the non-uniformity that can occur from some irrigation systems is the key driver in the variability across fields. Typically with sprinkler irrigation systems we have to operate in wind. And one of the things that we'll always see is that wind impacts the variation of water applied across a pattern. And nearly 20 years ago now we developed a package called TravGun, which is still freely available to assist us to improve the performance of travelling gun irrigation systems. And in the last 5 years we've done significant work towards improving the performance of end-gun systems on centre pivots using the same sort of ballistic sprinkler modelling technology that we have to actually allow people to understand the variation in the water depths being applied by these systems. And that's another package that's available to assist you to improve irrigation performance. When we look at solid set sprinkler systems, we can actually end up with this significant variability in water applied across fields with just standard solid set sprinkler systems. Packages available to actually assist you to go through the process of doing the sampling with catch cans and collectors to understand that variability, so that you then start to understand what that driver is in your crop production and therefore profit variability across fields. The challenge has always been that when you have a sprinkler irrigation system, you've got a rotating device and you're actually trying to typically irrigate square portions of field or triangular portions of fields or up against fence lines and other things. And here's a plot of the variability of the application rate of the sprinkler as we go from the centre on the left out along the radius, the radial distance, out to some areas out there at 10 and 12 metres. When we do the modelling, we actually have to take that measured radial leg information and plot it as a variation in depth, and then overlay those many applied depths of water to actually determine the true variability of the field. And so that you can imagine that's a troubling process for some, but the reality is when you actually take the time to do these things, you actually start to learn about the uniformity measures and the understanding of how the sprinkler spacing, as a simple thing on centre pivots, can actually impact grossly on the uniformity. Centre pivot packages and sprinklers are very expensive components, typically costing say 10% of the machine itself, but we've always said that they probably represent somewhere between 40 to 50% of the variability that can occur in a system. So getting them right is actually pretty important. Getting the sprinkler packages right is quite important. Here I've got a plot using that previous radial leg information and actually then running a analysis of the uniformity, which is on the vertical axis, and the higher the better, versus the sprinkler spacing as we stretch those sprinklers further and further apart. The red and the green line are those that occur from measured and simulated results there. And the occurring under a no-wind scenario. And then with the ballistic modelling capability we've actually then generated the information associated with impact under wind, when we've actually got wind blowing across the centre pivot itself. What you begin to see is that if we were to design a system at a reasonable spacing, might be out at something like 4 metres spacing of those particular sprinklers, under no wind that would perform reasonably well. But under a windy situation with a crosswind on that machine, that uniformity falls quite badly. And so it's a matter of understanding the performance levels of those irrigation systems in all potential ways. Things to do to help people understand what's going on. Our previous example with the dairy pasture, where we had a simple situation of not very precise water balance. There's tools that we've provided freely available for growers. Another one here called Scheduling Irrigation Diary. It simply allows you to locate your farm and field, drag information from the Bureau of Meteorology site for the closest weather station, and from that you can actually start to pull together a daily water balance of irrigation applied, rainfall that you can enter, and then understand what the variation in your soil water content is across time. The system that we've been redeveloping just recently allows us to simply map that on smartphone devices and iPads, and to start to select small fields or large fields simply by touching the screen, allowing a simpler data entry process. But that scheduling irrigation diary also available to assist you to manage irrigation systems a little better. So as I said, we need to be able to just start with something. Whenever you're trying to improve your irrigation performance, get in there and measure something. Start with any tool you can find or anything you can use. The previous example was one of a weather-based scheduling irrigation system. There are many others available. A fair few of them are free. Begin the process of measuring to manage. You can begin with those weather-based systems. You could utilise soil moisture sensors, of which there are a plethora. These are typically point measures, and under larger systems provide a bit of a challenge in translating that point measure of soil moisture to something that's occurring across the whole field. We need to overcome our fears about water meters being regulatory tools and actually use them to understand irrigation performance. That's pretty critical. Simple things like irrigation pressure at the pump or the centre pivot, shifted to you and translated so that it actually gives us good information, is essential to understand the performance of your system. And as I said before, remote control systems now allow you to translate some of that information to your hand, to your smartphone, so that you can actually monitor these things regularly. This will all help you with improving your irrigation performance. So just start somewhere. That's the important thing. Righto, to briefly touch on with 3 more slides very quickly, variable rate irrigation, and there's been a little bit of that spoken about this morning. The reality is that over the years in our work we've monitored up to 200% variation in irrigation requirements across fields due to soil, water holding capacity and other things, including elevation. And typically variable rate systems can be useful to actually gain a 10 to 20% water productivity improvement. Many people are utilising them not to actually grow more crop, but to actually simply exclude areas that they don't wish to have irrigated. And one of the things that you really must first ask is, am I getting the basics right before I start throwing 50 to 80 grand at a variable rate irrigation system on a centre pivot? Am I getting the first things right first? We've actually been in the process of developing automated prescription map generation for a variety of systems with our colleagues here at TIA. For both Zoomatic systems and for Valley systems, we're yet to work with some of the other good companies. But essentially, understanding that variability, we can actually start to then automatically generate the prescription maps and push them straight into the pivot control panels to produce things like this and allow us to understand the variability that's needed across fields. So in wrapping up this morning, I just really wish to thank the organisers for the opportunity to speak here, to emphasise to you the very great importance of understanding your uniformity of your irrigation systems, sprinkler systems itself, and to utilise some of the freely available technology that's around to help you improve your irrigation system performance. Thank you very much.